Alright guys, last video for this first chapter, and it's going to be on graphing rectangular hyperbole. So on the screen at the moment I've just got a rough of what a hyperbola looks like. Now you'll notice that it is a graph of two separate parts. We've got this part here which is in the positive x and y zone, and then this part here which is in like the negative x and y zone. So this type of graph shows a relationship of when one variable increases, say x increases, y decreases. Okay, so, and a good example to think of is the area of a rectangle. So the area is say constant, but if you want to change the width, then the length has to decrease. Okay, so if you want to increase the width, the length has to decrease, and vice versa. If you want to increase the length but keep the area constant, then the width has to decrease. Now this graph has two asymptotes in it. Now asymptote is a value where the graph never reaches, and in this case I've got asymptote at x is equal to 0, which is so basically the x-axis. So x is equal to 0, and the second one is here is y is equal to 0, so the y-axis. Okay, so y is equal to 0. So both of these are the asymptotes. Now a exponential, so remember an exponential looks like this, had only one asymptote. The hyperbola has two, so it's just something to remember. Now if you've seen the PowerPoint, you've seen the standard equation for hyperbola, so I've got that here. So here I've got the standard equation for a hyperbola, which is y equals a over x minus h plus k. So here h will give you the vertical asymptote, and its equation will be x equals whatever the value of h is. Okay, and k is equal to the horizontal asymptote, and that'll be at y equals whatever k is. Okay, now the direction of the graph, which is a, so that just means, say if a is greater than 0, then your graph will be in like this way. Okay, so if a is less than 0, then your graph will be this way. So what I mean by direction is it's just whatever, like kind of left or right orientated. I would say this way is right orientated, so it's kind of more positive. The top one is in the positive x values. This one's left orientated, where the top portion of the graph is in the negative x value. So our next example, we'll do y equals 1 divided by x minus 1 plus 3. So going from our standard form of our equation, which is y equals a over x minus h plus k. Now, for this one, a is bigger than 0, so it's going to be the positive version. We've got a h value, h is 1, so our horizontal asymptote is going to be at, sorry, our vertical asymptote will be at x equals 1, and k is equal to 3. So our horizontal asymptote will be at 3. We can still do, or we still have to do a table of values to determine our coordinates to be able to graph x and y. Now our limits for this one will do negative 4 again. This is equal to positive 4. Finish off our table. negative 4, negative 3, negative 2, 1, 0, 1, 2, 3, and 4. So we're going to sub in all these values into our equation each time to get our y values. So I'm not going to do that because it's going to take forever, but I'll 2 and 4 fifths, 2 and 3 quarters. So if x is negative 2, 2 and 2 thirds, negative 1, we get 2 and a half. If x is 0, we get 2. If x is 1, we get undefined. So there's our asymptote there. If x is 2, y is 4. If x is 3, we get 3 and a half. And if x is 4, we are at 3 and 1/3. So just now we will draw our axes. So x values, as usual, are going to go to negative 4, and 2, 3, and 4. Now, biggest y value is at 3 and a third. Sorry, what's that? 4? No, not 4. 4, 2, 3, 4. Now I'm just going to dot in our asymptotes. So we've got it at, so h is 1, so our asymptote there is x. So h is 1, so our asymptote is at x equals 1, and y equals 3. This will help us draw our graph better. And that one was at x equals 1. So we're going to draw this down here. Very straight. It's meant to cut through. This is 1. And next we'll just do our points. So we've got that 4y is at 2 and 4 fifths. So it's nearly 3. So I've got 2 and x is negative 3, y is 2 and 3 quarters. Again, nearly 3. Negative 2, so we've got 2 and 2 thirds. We're staying pretty close to this asymptote there. And 2 and a half, that makes equals negative 1. So we've got 4 points there. At 0, y is 2, that's the 5th point. And we've got 1 is undefined, so we've already got our asymptote in. X equals 2, y equals 4. And then 3, we've got 3 and a half. And at 4, we've got 3 and 1/3. Over there. Now you can, by all means, do extra points in your table. Like you could do, if you wanted to get a really nice view idea of where and how close to the asymptote you're going to get, say here. So on the so if you get closer to x equals 1, You could do some extra values. You can sub in values between -1 and 0. So -1/2, -1/4, -2/4 to get some extra points. But we can still just graph. Remember our limit was -4, so I'm going to stay there. I'm going to join these points and hopefully not Kevin backwards, so we can do that. Why I do every time I do this, that's right. Okay, we're going to go that way. So it's come up from there and it's going to come down there, but never cut that. Okay. So there is our graph. And it is a graph of y equals 1 over x minus 1 plus 3, where our asymptote here is y equals 3, and this one down here is x equals 1. So if you have any questions about those, please email me. If you'd like me to do another example, then also let me know via email. My email is up on Compass if you want to double check what that is. Alright, you should have written it down in class on Thursday. Enjoy, guys.